Physics is hard. What is kinematics?
Kinematics includes the idea of average velocity. Average velocity is different than average speed because average speed is the distance traveled divided by time, while average velocity is the displacement divided by time. We can find the displacement on the graph by adding the change in y to the change of x and dividing it by the time.
Average acceleration is defined as change in velocity over change in time. Average acceleration is the same direction as change in velocity. It changes its direction if change in velocity increases in magnitude or it changes its direction. To find average acceleration, you have to find change in velocity, which is velocity of vector b plus the negative of velocity of vector a. And drawing the change in velocity in the original diagram will give average acceleration.
Hello, my name is Professor Zach, apprentice to Professor Maddie A. I'll be teaching about projectiles. A projectile is an object that moves in 2 dimensions only influenced by gravity. It moves in a characteristic parabolic motion like this pictured. The constants and key properties are the acceleration in the y direction is always going to be gravity, acceleration in the x is going to be 0, the velocity in the x direction initial is going to be the same from start to finish, and the hard thing is it is moving at a diagonal. But since we only work with horizontal and verticals, we have to break it up into the vertical and horizontal components with these 2 equations right here. We use these constants and key properties in these equations down here, which we'll be showing examples next.
Wow, this isn't too bad. You could apply it to a video game.
I guess I could.
I know my superior knowledge in kinematics can help me out to eliminate more enemies than I've ever seen before, such as right now.
Suppose I wanted to kill someone with Junkrat from 100 meters away at about a 45-degree angle. So, consider the mass of the projectile, which would be about 3 kilograms, the initial velocity, which would be 30 meters a second, and the angle I'd be shooting at, which is 45 degrees. We have it mapped out here where we have the angle, the initial y value is 0, so the displacement on the y-axis, and the initial displacement on the x-axis is 0, and we have the final y is also 0 again. We have listed up here that the acceleration on the y direction is going to be the negative gravity, which is negative 9.8 meters a second squared. And for the x-axis, there will be no acceleration. So, keeping that in mind, we can start off with the formula y of the final is y of the initial plus the velocity of y initials times the time plus 1/2 acceleration on the y, t squared. And we get this from our basic kinematic equations. So once we plug in the values, we get 0 for the final y displacement and 0 for the initial y displacement plus the initial velocity sine theta t, which we get by having the mapping out down here. We see the velocity is going this way, so in order to find the velocity on the y-axis, it's going to be the sine. So sine t minus 1/2 gravity t squared. So we go through our simplification, bring the negative 1/2 t squared times gravity over to the other side, simplify it out to t equals 2 times initial velocity sine theta over g, and then after we plug in the numbers, we get 4.3 seconds. From there, we can use that to find how far the projectile travels. Now over here, we have the xf, which is what we want to find in the end, equals xi, which is the initial displacement, plus the initial velocity, t, plus 1/2 acceleration, t squared. So, we leave this variable here as that's what we're trying to find for. The initial displacement on the x-axis is 0, and then the initial velocity in the x direction is v initial times cosine theta times t, and then we actually have a 0 acceleration, so that makes this entire 1/2 acceleration times t squared equal to 0. From there, we plug in our numbers, and we get 91 meters. So the answer is no, we would not.
Nope.